A very good morning to all my 8th class students. Children, hope you are following all my classes related to our 14th chapter, Chemical Effects of Electric Current. And I hope you have completed your 13th chapter, Notes 2, Sound chapter, right? I'll be conducting few tests before the examination based on these two, the syllabus of PA 3, that is 13th and 14th chapter. Before that, let me just finish off this lesson. There's the last topic left, and it's also an important topic, children. Okay? So, as you know that in my last class, I just gave a glimpse, nothing but a small introduction to a very important phenomenon, that is electrolysis. Hope you remember that electrolysis term, it can be broadly understood by breaking it like this. So electro means electricity and lysis means to break down. So this is exactly what electricity is doing to different compounds, whenever different chemical substances. Whenever electricity passes through a solution, a chemical solution, then it tends to break down that substance into its individual constituents. I told you that if electricity is let into water, what is the formula of water? It is H2O. H2O. So this, if electricity is allowed to pass through water, what will happen? As the name indicates, it breaks down. It breaks down the compound into its individual constituents. With what elements is water made up of? We know that it is made up of hydrogen and oxygen. Whenever electricity passes through it, it breaks down this compound into individual constituents. Hydrogen and oxygen gas is released out. So what is this? Why did I put these arrow marks? It indicates that it is a gas that is liberated. Correct. So in the similar manner, if it is any other chemical substance, the electricity tends to change its chemical composition, to break its chemical composition such that the individual constituents are separated. So electrolysis is such an important phenomenon. It has got an array, so many applications that we follow in our day-to-day lives actually. So one of the very important applications of electrolysis is electroplating, children. Before I come to this, one small point I would like to add to this. Here you can see H2 and O2. If you see the volumes, okay, if you see the volumes of hydrogen and oxygen, you will see that after electrolysis, you will see that the volumes of hydrogen and oxygen will be in the ratio 2:1. That means 2 volumes of hydrogen gas and only 1 volume of oxygen. The ratio will be, which one will be more? Hydrogen will be more. 2 volumes of hydrogen, that means double the amount of oxygen, hydrogen will be present. Okay? And the scientist who has introduced, or what you call invented, who has discovered this effect of electricity, he is nothing but William Nicholson, children. Nicholson, okay? He has done this experiment of electrolysis and he elucidated, nothing but he chemically proved that when electricity is passed through water, we get hydrogen and oxygen in the ratio 2:1, children, okay? So, coming back to electroplating, which happens to be one of the most important applications of electrolysis. What is electroplating? It is coating a metal, a costlier metal or a better metal over a cheap or, a cheap metal. That is called as electroplating. Here, what are we doing? We are coating. Very even. You may just get a doubt now that why don't we just dip it in molten metal and that is enough, isn't it? So you take a small iron ball, you dip it into gold solution when it is in molten state, molten gold, and you get a cover of gold over the iron. You may get a doubt like that, but that will not have any bonding here, children. That will not last for long. It would chip out like anything. So electroplating, what is the difference between that and electroplating here? Electroplating, it involves bonding of that particular layer of gold or whatever better metal that you wish to coat over. So electroplating is nothing but coating a better metal over another metal by way of electricity, with the help of electricity. Electro electroplating. So we might have seen, many of our household things also are electroplated, like the circuit boards that are there. So you have, like in every electrical appliances, we have a motherboard, circuit boards and all, in which the connections are actually made with some metal, right? Because we should have a complete circuit. Whenever a simple remote control, if you see, if you just open it, you will find a green colored board, right? So you'll have all metal connections, circuits that are in the form of lines. You can see very tiny and very thin lines connecting different points together. So those all boards are made by using this electroplating method only. It's very difficult actually to pour in the metal directly like this, isn't it? Very fine lines you can see. Such circuit boards can be made by using this procedure, electroplating. Also some gilt ornaments, the ornaments like the earrings or the necklace or whatever, these ornaments which are made up of a cheaper metal can be made more lustrous and shiny by using this electroplating. Gold plated ornaments, have you heard of this? Yeah, 1 gram gold plated ornaments and all these are mainly made by using this procedure only, electroplating. So you'll have a warranty for it, right? So the color doesn't easily go off. It doesn't easily go off. That is because it is very strong bonding will be there between the two metals. That's why nothing will very easily, it will not chip out. Okay. Next, the parts of the machine. We know that one of the major problems of the parts of the machine, if they are made with some metal which could easily get rusted, like the iron parts and all that, iron, small parts of iron and all, they easily get rusted. So to avoid rusting, what do? We have got some various procedures to avoid rusting, to prevent the iron from rusting. We have got some various methods, like we can galvanize the iron, or we can simply paint it and all that. And there are like some other metals also which easily get worn and torn. So in order to prevent such rusting or such damage to the parts of the machine also, those cheap metals are coated over with a better metal which do not get rusted easily. So there also the parts of the machine, like they are again they are made with this electroplating only. Even the utensils, we have seen that the copper bottom utensils and all, have you seen that? So again, a steel utensil, it can be coated with copper using this electroplating. So now coating of copper actually enhances the quality and durability of that particular utensil. So what is the basic aim in order to improve the quality? We are doing all these things to improve the quality. Also the conducting, the heat conduction will be better if the utensil has a copper bottom. And how is that copper? It's not a paint so that you can paint off. We can't do that. So copper can be coated over the steel using electroplating. Got it, children? Now how is it done? It's again the same electrolysis process that we have seen in our last class. What do you take? You take a container and you add a metal salt solution, and a metal salt solution should be of the same metal which you wish to coat. For example, if you wish to coat a substance with copper, the metal salt solution should be a copper salt solution. So if I wish to coat this particular coin or anything, any particular object with copper, then I have to take a copper sulfate solution. Got it? And we know, I would like to just refresh your knowledge about ions. We have like two types of ions. We have anions and we have cations, right? So those which have a negative charge, they are called as anions, and those which have a positive charge, they are called as cations. We know this. Now we know that these ions, they tend to, the like charges, they repel, and the unlike charges, the like charges repel and the unlike charges attract each other. So the negatively charged ions, always they are attracted towards a positive electrode. We know that you can see over here, there are two electrodes which are connected to the battery. Why am I saying that this is a battery, children? Do you remember the difference between a cell and a battery? Yeah, if I draw only one long line and one short line, it means that it is one cell. If I draw many such, more than one, then it is called as a battery. So you can see here one long line, positive terminal, one short line, negative terminal. In that way we have some 2 or 3 cells, and at the end we have one more cell connected together. Together we call that as a battery, a set of cells. Now you can see that this electrode is connected to the positive terminal of the battery. So this electrode is called as anode. Here you have this electrode connected to the negative terminal of the battery. This is called as cathode. You have to understand over here, remember forever that anions move towards anode, cations move towards cathode. AACC. Anions move towards anode, cations move towards cathode. Now anions, which charge do they have? Negative. And anode, which charge does it have? Positive. So the negative ions always move towards the positive electrode. And the positive ions, which are nothing but cations, they move towards cathode. This is slightly confusing for you. Many students actually they get confused with anode, anion, cathode and cations, and they just mess the things up. Please do remember, always remember, anions negative, cations positive. Anions move towards anode, an. Cations move towards cathode, cat. Okay. Now, in order to electroplate copper, I wish to electroplate a small coin with copper. Then what I have to do? I have to connect, okay, I have to attach a pure copper plate, okay, metal, to the anode. Very important, please do remember, always the metal which you wish to coat should be connected to anode. It's a very important bit. It is asked in many competitive exams also. To which electrode is the metal to be coated? Metal to be coated attached. It should be to the anode, children. Okay. Now here we have copper. Pure copper plate you have to take. And what solution? Which solution you have to take all this? We have to take the same copper metal solution. It can be a copper sulfate. Got it? Now, the object to be electroplated. Please try and understand. The metal to be electroplated, we wish to coat that particular object with copper. That has to be connected to the anode. And we have the object to be electroplated. The object to be electroplated should be connected to the cathode. Now what happens when you switch this on? When you make the connections, everything, when you make this circuit a closed one, electricity will pass through it. Because copper sulfate also is a salt solution, it will allow electricity to pass through. Now what will happen? This copper sulfate, okay, the copper over here, the copper sulfate solution, it will now, what will happen? Electrolysis will happen, and it will just split into copper and sulfate ions. You can see the copper ions are positively charged, 2+. So what are they called? These are cations. Will they move towards anode or cathode? Positive, no? Cations, they will move towards the cathode. So all this, the metal salt solution, copper sulfate solution, all the copper that is present in the solution will now start, what happens? It will start moving towards the cathode. Now this electrode has the object that we wish to coat. Now, so all the copper will go and cling, nothing but a coat, evenly that object gets coated with copper, and the sulfate remains in the solution. Now another thing happens over here, the copper over here, okay, this also gets ionized, and what will happen? It will go into the solution. Now ultimately what will happen? This copper goes into the solution, and the copper that is present over, the sulfates will be present here now. It will combine with the sulfates and form copper sulfate again. And again from the copper sulfate, this happens. Splitting of copper and sulfate. The copper will go to the object. For example, if you don't take any copper, then also the coating will happen. Because copper is already present in the metal salt solution. From this, the copper will get coated to the object. So the object to be coated always has to be connected to the negative, because the positively charged ions will always move towards the negatively charged cathode. Correct? So in that way, this piece of iron or any other cheaper metal, it gets a very nice and even coat of the metal that we wish to coat. If it is copper, copper. If it is gold, gold. But you have to keep in mind that whichever metal you are thinking or wishing to coat, that metal solution only you need to take. Correct? So that's how you've got many other applications of electroplating. I would like some of my students to present a small PowerPoint showing the applications of electroplating. Will you do, children? Thank you.